Hello, good day viewers. You are welcome back to Shabes online tutorial. In our last tutorial, we learned how to solve homogeneous differential equation when the root is distinct, and I show you how to write the general solution when the root is distinct. So in today's tutorial, I'll show you how to solve this interesting another homogeneous differential equation. Let us see whether the root is going to be distinct root or equal rule or a complex rule. So let's get started. Solution. So like I told you the other time, when you are given, this is a second order homogeneous differential equation because it's equal to 0. When it's equal to any number or any variable that is except 0, it's going to be what? Non-homogeneous differential equation. But in this case that is equal to 0 is going to be what? Homogeneous differential equation. So the differential equation is given as y prime prime minus 10y prime then plus 25y, which is equal to 0. So like I told you in our previous class, the first thing to do is to write the auxiliary of the equation. So the first one, the coefficient is 1, so we can use m to represent the auxiliary. It's going to be m to the power 2 because it's the second order, then minus 10 m to power 1, then plus 25 is constant, which is equal to 0. So this is the auxiliary of this equation. And we notice that this equation have led us to what? Quadratic equation. Now we are going to use formula method to get the two roots of this quadratic equation. And the formula method is what? We have, let us identify our a, b, and c. A is what? The coefficient of m squared is 1. Then b is what? Minus 10. Then c is equal to 25. Now we can use the general formula of quadratic equation, which is what? Minus b plus or minus square root of what? B square minus 4ac, everything all over 2a. So from the question, b is what? Minus 10. And the formula also have minus. We are going to have minus into minus 10 plus or minus square root of b is what? Minus 10 square. We are going to have minus 10 square minus 4 into a. A is 1. Then multiply by 25, which is c. Then everything all over 2 multiplied by a. And a is 1. So now we can continue to simplify this. Minus times minus is going to give us what? Plus 10. Then plus or minus square root of what? Minus 10 square. Recall, if you have any negative number, you can press calculator. Minus 10 square to give us minus 100. But if you have any negative number raised to the power of even number, the result is what? Is always positive. It will give us always positive result. So in this case, we are going to have 100, then minus 4 times 25 is going to give us 100. So everything over what? 2. 2 multiplied by 1 is going to be 2. So now we are going to have what? 10 plus or minus square root of 100 minus 100 is going to give us 0, and everything over 2. So the two root of this equation is going to be what? 10 minus 0 over 2, or 10 plus 0 over 2. So m1 will be equal to 10 minus 0 is 10, then 10 divided by 2 is going to give us 5, or m2 is equal to what? 10 plus 0 is 10, then divided by 2, it will also give us 5. So in our last class, the root that we have is distinct root when the roots are not equal. But in this case, look at the root 5 and 5, they are equal. So recall in our last class, the general solution we use when the roots are unequal is what? Y is equal to c1 e to the power of m1x, then plus c2 e to the power of what? m2x. So this is the case when the roots are unequal. But in this case that the roots are equal, the general solution we are going to use is what? Y is equal to what? c1 e to the power of m1x plus c2. So we are going to multiply x to this second one so that it will be different from the general solution when the roots are unequal. We are going to have x exponential m2x. If you notice that there is x here, but there's no x here, so that will make this one different from the previous one we used. So substitute to the general solution, we're going to have what? C1 exponential m1 is what? 5x, then plus c2x exponential 5x. So this is the general solution of this given second order homogeneous differential equation when the roots are equal. And in this case, this is what we solved in our last class when the roots are not equal. So in my next video, I will show you how to write the general solution when the the root of the quadratic equation is complex. Its complexes defend in the sense that when you have, maybe you solve quadratic equation, the root, you have something like 5 minus 4i, I is complex number, or 5 plus 4i. This is complex root. So the general solution for this is also different from these two general solutions. So this is how to solve second order homogeneous differential equation when the roots are equal. Thanks for watching, and please don't forget to subscribe to my YouTube channel. Also follow me on Facebook, TikTok, Instagram at Shabes Online Tutorial.